In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe.
In the distant corners of our solar system, ice giants Uranus and Neptune are violent worlds. Blanketed with smoky hazes, these outer planets are frenzied, turbulent, and unpredictable. Neptune claims the fastest winds in our solar system. Like an apparition, its great dark spot surfaces and vanishes without warning. Uranus's inner swarm of moons dash around the planet in less than a day, and collisions are unavoidable. The most controversial of the far-off planets isn't even a planet anymore. So why was Pluto demoted? The man who killed Pluto makes his case as we explore the outer planets. Meet the man who killed Pluto.
Pluto had it coming for a long time.
Caltech astronomer Mike Brown set in motion a chain of events that reduced the long-established number of planets in our solar system from 9 to just 8. Yet he feels no remorse.
There was no way that Pluto could survive its status as the single lonely ice ball, but it was gonna fall, and it certainly fell.
Among our planets, Pluto was long considered to be a bit different. Much smaller than the rest, it has the largest moon in proportion to its own size. It also has the most inclined and eccentric orbit.
Its orbit is sort of shaped like an egg. Pluto's orbit causes it to get significantly closer to the sun and then further away from the sun.
This cosmic needle in a haystack eluded planet hunters for decades. The 8th planet, Neptune, had been discovered in 1846, and astronomers at the turn of the century were convinced there was a 9th planet in the far reaches of our solar system.
The search for Pluto was started by Percival Lowell at Lowell Observatory. He thought there was a planet X there that was perturbing the orbits of Uranus and Neptune.
Before finding the elusive planet, Lowell passed away. But the observatory's research assistant, Clyde Tombaugh, continued his quest. In 1930, at the age of 24, Tombaugh captured an image of an object that seemed to validate Lowell's predictions. The discovery was announced to the world, and the object was given an official name, Pluto. But was Pluto Planet X? Some scientists argued that Pluto was far too small and didn't have enough mass to significantly perturb the orbits of its neighboring gas giants, Uranus and Neptune. Astronomers have since realized that there is no such Planet X. It had been predicted using inaccurate estimates of Neptune's mass. Even though Pluto wasn't Planet X, could it still be classified as a planet?
The first term for planet just meant wanderer in the sky. It was the things that moved relative to the stars. So to the ancient Greeks, the moon was a planet, the sun was a planet, the earth was not.
Of course, when we realized that the Earth is actually going around the sun and that the moon is going around the Earth, the definition of planet changed again. Earth became a planet, the sun and the moon were taken away, and there were finally 6. And over time, Uranus was discovered, and Neptune was discovered, so there were 7, there were 8.
Although it later proved to be smaller than our moon, Pluto was originally thought to be as large as Mars. So Tombaugh's discovery was anointed as planet number 9.
No one really thought much else about it. It was a strange object. It was sort of this lonely oddball at the edge of the solar system, but nothing else to call it, so it was called a planet.
Because of its great distance from the Sun, Pluto takes its name from the Roman god of the underworld. At its closest, Pluto is 2.7 billion miles from Earth. Its diameter is 1,485 miles, half the width of the United States. It takes 248 Earth years for Pluto to orbit the Sun. And a day on the planet is equivalent to about 6.5 Earth days. A 150-pound Earthling would weigh only 10 pounds on Pluto. It's a testament to modern technology that we know anything at all about the surface of Pluto.
We can hardly see this thing. Even with the Hubble Space Telescope, we get maybe 4 pixels across, maybe 12 pixels total. But even with that, we see that parts of Pluto are as dark as coal and parts of Pluto are as bright as snow.
Even from afar, scientists can measure the composition of the planet. They believe that the bright areas of the surface are made up of 3 types of ice.
Well, one is carbon monoxide, one is methane, which is the same as natural gas. And then the third is nitrogen, the same stuff that we have breathing here in our atmosphere.
The dark areas are probably solid rock.
The darker areas are almost certainly silicates of some sort. Silicates not unlike the rocks that we see here. That means there's silicon in them and there's oxygen in them. We're up here in Rocky Mountain National Park in Colorado. There's some snow around, there's some rocks around. This is similar to what we're going to see on the surface of Pluto.
A traveler to Pluto would find that despite the snowy surface, it is a very dim place.
About 30 or 40 times further away from the sun than the Earth is. This means that the sunlight hitting the surface of Pluto is about 1,000 times fainter than it is on the Earth. It's maybe about the same brightness as being outside under a dim street light at night. You could probably, you could take a book, you could probably read it there. Take a headlamp though, take a flashlight, it'd help out.
Its distance from the sun also makes Pluto one of the coldest places in the solar system, with a bone-chilling average temperature of minus 388 degrees Fahrenheit. And because of its small size and low density, gravity on Pluto's surface is far weaker than on Earth.
Now, some things are going to be a little easy to do on Pluto if you're really into rock climbing. I'm doing some vertical climbing here. Well, it's always exciting, but gravity is always the challenge.
Pluto's gravity is roughly 1/15 of the Earth's.
It's not like if you're standing on the surface, you would float away. Now, if you fell off that face when you were climbing up Pluto, you'd still want to have your rope there. You'd still accelerate down to the surface. So don't leave the rope at home.
Scientists would love to chip away at the surface of Pluto because hidden within its rocks is a whole missing chapter in the history of our solar system.
Pluto's a great planet. I mean, it's what I think is really great about it. It's sort of the ultimate time machine in our solar system. It really shows us what the environment of the solar system was like 4.5 billion years ago when it's formed. The surface there is much more ancient than you're going to find almost anywhere else in the solar system. And if you're looking for rock on the Earth has been around for that same time period, 4.5 billion years or so. But if you're looking for rock that's that old on the Earth, you're not going to find it. And that's because the Earth is sort of constantly recycling its material. You have plate tectonics going on that sucks all this material back into the mantle. You have volcanism going on that pumps out new material and processes the surface. So it's really a much younger surface on the Earth compared with the ancient surface that we're going to see on Pluto. The rocks that we're sitting on here have been processed by the high pressures in the Earth. On Pluto, it's more primitive.
Primitive, but far from pristine. Pluto is likely riddled with impact craters.
Impact craters are caused by asteroids or meteoroids impacting the surface. These are essentially pieces of the solar system that were never made into planet. Out of the surface of Pluto, you don't have an atmosphere, you don't have glaciers, you don't have winds, you don't have rain, you don't have erosion. And so the one dominant feature that you see on the surface is probably going to be a lot of impact craters.
Pluto's pockmarked surface undergoes a transformation as it orbits near the Sun. Under the additional heat, some of the frozen gases evaporate to form a temporary atmosphere. As Pluto recedes from the Sun, the gases freeze again and fall back down to the surface. For more than 75 years, this far-out icy object staked its claim as our 9th planet. So why is this little piece of snowy rock now causing such controversy? Why was Pluto kicked out of the solar system's most exclusive club? It's a quiet office at the Caltech campus in Pasadena, California. And it was from here that Pluto's demise as a planet began. But astronomer Mike Brown was never looking to destroy a planet. Equipped with Palomar Observatory's 48-inch telescope, he was seeking out Pluto-sized worlds at the far reaches of our solar system. And in 2005, he found one, an object bigger than Pluto, with its own moon, both orbiting the Sun.
When I first found this thing that's bigger than Pluto, I was looking through the images that the telescope had taken just before, and I found it in the screen. And did a very quick calculation, realized it was bigger than Pluto. And the very first thing I did was picked up the phone and called my wife and told her I just found a planet.
Indeed, if Pluto was a planet, and for more than 70 years it had been, then why wouldn't Brown's new world be considered a planet too?
I thought it was the 10th planet. For a long time, that's how I described it. It was a planet, and so I definitely felt like I had found the 10th planet. It's 5% bigger than Pluto. It's probably made out of the same materials on the inside, rock on the inside, ice on the outside, and a little thin layer of frost on the very outside that sometimes puffs up into an atmosphere and sometimes doesn't. Very similar to Pluto in that way. It has a moon that goes around it once every 16, 17 days. Pluto has a moon also, so it's, in many ways, I like to think of it as almost as twins. This is just the twin that just ate a little bit more when it was a baby, got a little bigger.
Brown considered naming his object Xena after TV's warrior princess, but eventually the name chosen was Eris, after the Greek goddess of discord. As it turned out, this name was entirely appropriate. The discovery kicked off a firestorm in the astronomical community. Now, the very definition of a planet was being hotly debated. Would Eris officially become our 10th planet, or would Pluto-sized objects be reevaluated as a whole? The argument was brought to the table in a 2006 meeting of the International Astronomical Union in Prague. a vote was taken and the term planet was defined scientifically for the first time.
Those who are in favor of Resolution 6A, which introduces this new category of trans-Neptunian objects with Pluto as a prototype.
The recommendation is that we consider Pluto and other similar trans-Neptunian objects to be in a special class.
We didn't reconsider Pluto's status because we learned anything new about Pluto that made it less interesting.
Instead, scientists say the issue was addressed because they learned about Eris and other large Kuiper Belt objects. The Kuiper Belt is a 3.5 billion mile wide region in the outer solar system near Pluto. It's home to hundreds of thousands of icy objects, the first of which was discovered in 1992.
So historically, we've thought of the outer solar system where you've got Uranus and Neptune out there. There are these big gaseous planets, giant planets. And then just beyond that, you've got this little straggler Pluto that doesn't really fit into the picture. Well, now when we found all these other Kuiper Belt objects, what we're seeing is that maybe Pluto is really just the first of these many, many bodies of the Kuiper Belt that are this wide diversity of small icy bodies at the outer solar system.
The result of the IAU vote stipulated that a planet is a spherical object that orbits the sun and clears out the neighborhood around its orbital path. Since the area around Pluto is full of other Kuiper Belt objects, the new definition would leave Clyde Tombaugh's great icy discovery out in the cold. Pluto's 76-year reign as the 9th planet was over. Our solar system would now officially consist of only 8 planets. Objects like Pluto and Eris were given the new classification, dwarf planets. Dwarf planets possess the same characteristics as planets, but do not have a clear orbital path. Under the new definition, Ceres, the largest asteroid in our solar system, is also a dwarf planet.
We have this new terminology because there's more things in the outer solar system than we used to think. It's like all you could see was one skyscraper, and now all of a sudden you have a whole city in front of you. We have a whole city full of objects in the outer solar system now.
The IAU vote was meant to settle the debate on what constitutes a planet, but many scientists refuse to accept the outcome.
There are astronomers who want it to be a planet still, and they just keep ripping those scabs off whenever possible, and they want to keep it fresh.
I believe Pluto is a planet. And I don't think the question of whether or not Pluto is a planet is really that important. Fundamentally, it's not a scientific question, it's a question of names. But in a way, in an odd way, it's become one of the highly visible subjects of planetary science.
People always ask whether Pluto is a planet or not. There's not one easy dividing line. There's not where you move from being a planet over here to being a planet over here to being not a planet over here, just like there's no real dividing line between a stone and a pebble. It's really more of a sociological question. It's a question of definitions of words rather than a question of science.
Although no longer officially a planet, scientific interest in Pluto hasn't waned. Even as the vote was being taken in Prague, a NASA spacecraft called New Horizons was already on its way to exploring this far-off world. The New Horizons mission will be the first spacecraft ever to visit Pluto.
By going to Pluto, studying Pluto, it's no longer a mission to a singular object, but it's actually a mission to one of a class of objects that we'll get to learn about.
But New Horizons needs to travel at warp speed, or a valuable research opportunity to study Pluto's atmosphere will be lost for at least the next 200 years. The New Horizons spacecraft is headed for a rendezvous with Pluto.
We have confirmation of spacecraft separation.
But scientists are trying to beat the clock. Because as Pluto recedes from the sun, its 62-year-long winter is coming. And when winter comes to Pluto, the dwarf planet's atmosphere will freeze and fall to the ground.
If it collapses too much, it might just be a lot less interesting. You might not have as interesting chemistry. And we want to know what the temperature and the composition and the structure and the winds on the atmosphere.
To get there in time, New Horizons is blazing through the solar system at more than 45,000 miles an hour. That's 12 miles a second. At that speed, a trip from Los Angeles to New York would take about 3.5 minutes.
So this is the fastest spacecraft that was ever launched from the Earth. In fact, it took about 6 hours to get out to the 250,000 miles to make it out to the moon. You can compare that to the couple of days that it took the Apollo astronauts to get out that same distance.
New Horizons would pass by Jupiter in just 13 months. But the outer solar system is so big that it's going to take us another 8 years to get to Pluto.
Even with its unprecedented speed, New Horizons won't reach Pluto until July of 2015.
Pluto's just a big mystery. It's exciting to me that there's a spacecraft on its way there, and that in a few years we'll, this sort of blank slate of a world will be richly filled in with pictures and detailed data.
About 4 billion miles from Pluto, Uranus is a mesmerizing blue marble.
And it's really strikingly beautiful and different from the other planets. It's a giant blue, pale blue, fuzzy ball sitting there in space against the darkness of space. And it's just that striking blue color and the almost pure featurelessness of it. It seems unreal. It looks as though it was sort of created by some movie special effects person. Because how could you have a planet that large and that perfect and just this giant featureless blue?
Uranus is 1.6 billion miles from Earth. It has a diameter of nearly 32,000 miles, 4 times Earth's diameter. It takes 84 Earth years for Uranus to orbit the Sun. 1 day on Uranus is a little over 17 hours. If you weigh 150 pounds on Earth, you would weigh 133 pounds on Uranus. Named after the Greek god of the sky, Uranus has the most off-kilter axis of any planet in the solar system. At an angle of 98 degrees, the planet is actually spinning on its side.
What that means is that at one time of the year, only one hemisphere is pointing towards the sun. The other hemisphere is complete darkness. The time for Uranus to orbit the sun is about 84 years, which means that for half of that time, or 40 years, one hemisphere is in sunlight and the other hemisphere is in dark.
It's like the Arctic Circle on Earth, except for it's the whole planet. That tilt is so extreme that in a sense, the whole northern hemisphere is the Arctic, and the whole southern hemisphere is the Antarctic.
Uranus owes its cool bluish-green color to methane. The methane absorbs red and orange wavelengths from sunlight, but reflects blue and green. And its soft appearance is due to something that's familiar to anyone who lives in a big city: smog.
In Southern California, we're used to smog, which is photochemically produced haze material, which gives this hazy appearance in the atmosphere.
This is similar to the atmospheres of the 4 gas giants.
In the outer planets, there's methane, which is natural gas. Sunlight converts it to complex particles as well, which forms a haze, which is the reason the planets don't have a very sharp, but have a fuzzy look to them.
Scientists speculate that Uranus and its celestial neighbor Neptune formed the same way. As the early protoplanetary disk of gas and dust in our solar system settled, Jupiter and Saturn gathered up the most material and became the largest of the gas giants. As Jupiter and Saturn's orbits grew, they destabilized the planetary system as a whole. Dynamic interactions pushed Uranus and Neptune outward to the edge of the solar system at an accelerated rate, where they feasted on icy objects.
They have a lot of that initial gas, but they also gathered a lot of icy material and some rocky material in their formation. So consequently, although they have this surrounding envelope of hydrogen and helium gas and some methane, some nitrogen, some other stuff, they also have a lot of icy material in the inside.
These icy interiors have led some to call Uranus and Neptune the ice giants. But it's incorrect to imagine them as balls of solid ice that an astronaut could walk across.
Well, if we dropped an astronaut or a probe towards the center of Uranus or Neptune, well, first of all, they'd be in a lot of trouble. There's really no solid surface that they could stand on. There may be a small rocky core at the center of these planets, but the pressure that they would be experiencing from the atmosphere overhead and this liquidy, icy region would crush them. It would be millions of times the pressure that we have from our own atmosphere, for example. So they would be flattened well before they ever reach the solid surface.
While the other gas giants have wild weather patterns, Uranus seems to be relatively calm, and scientists think they know why.
Uranus is unique among the gas giant planets in that it is the only one that doesn't have an internal heating source. Jupiter, Saturn, and Neptune all have heat coming from deep within the planet, and that helps drive the circulation, and it explains why we see a lot of the banded structure that we do on those other three planets. Uranus doesn't have this internal heating source.
Uranus has another claim to fame, the way in which it was discovered by astronomer William Herschel in 1781. At the time, the only known planets were the 6 visible to the naked eye from Earth. But Herschel first laid eyes on Uranus through a telescope.
Herschel was an amateur astronomer, professional musician, and an optician, so he had the knowledge and ability to generate the best telescopes in the world at the time.
The discovery of Uranus was incredibly significant in the history of humanity because it was the first planet discovered by telescope, the first planet that the ancients didn't know about.
In 1977, NASA's Kuiper Airborne Observatory made another exciting discovery when astronomers aimed their telescope at Uranus. They were planning to watch a fairly common astronomical event, the passage of the planet in front of a star. But as Uranus closed in, the star suddenly winked. In fact, it seemed to flicker on and off 5 times as it neared the planet, and then several more times as it emerged on the other side. What was the cause of this strange phenomenon? The flickering star was actually passing behind 5 planetary rings, features that had only previously been seen on Saturn. Subsequent observations from the ground and then the Voyager spacecraft confirmed the ring's existence. And observations made in 2005 from the Hubble Space Telescope found a second set of rings orbiting almost twice as far away from the planet as the previously known rings. Unlike Saturn's thick icy rings, Uranus's are dim and thin, comprised of dark, rocky dust. Some of Uranus's dusty rings were likely formed by the impact of a meteor or a comet with one of the planet's 27 moons. The inner rings could be the result of collisions between the moons themselves, especially the 13 that orbit in the planet's kinetic inner swarm.
There are a lot of inner moons around Uranus, moons that are very small and close to the planet. They tend to have very fast orbits on the order of maybe a day.
Other moons zip around Uranus in just 12 hours. By comparison, our moon circles a planet 4 times as small and takes 28 days to do it. With Uranus's moons speeding around the planet like race cars, it's only a matter of time before 2 of them end up in another cosmic collision. Circling the planet Uranus is a swirling system of moons. Even within the last decade, substantial changes have been detected in their unruly orbits. Scientists believe it's only a matter of time before 2 of them cross paths.
We can be very certain that in a period of a million or a few million years, that some of them will collide with each other.
I'm thinking particularly of Cupid and Belinda, which are 2 small moons that happen to be orbiting very close to each other.
Traveling at just a few hundred miles apart, scientists expect that at some point, these moons, due to gravitational forces that they impart upon each other, will eventually collide and rip each other apart. It will be a bad day for the moons, but a welcome event for the planet's ring system.
The debris that's released from that can potentially generate a new ring around Uranus.
Uranus shares the outer solar system with its sister planet Neptune. A gleaming sapphire some 3 billion miles away from the sun. With the demotion of Pluto, Neptune is now our outermost planet. Neptune takes its name from the Roman god of the seas. Neptune is 2.68 billion miles from Earth. Measuring roughly 30,000 miles, Neptune's diameter is 4 times that of Earth's. A year on Neptune is equivalent to 165 Earth years, and a day lasts 16.1 hours. If you weigh 150 pounds on Earth, you would tilt the scales at 169 pounds on Neptune. Like all the outer planets, Neptune rotates much faster than Earth, and this rapid spin helps to create violent winds.
In fact, the highest winds recorded on any planet in the solar system are on Neptune. You have winds of sometimes over 1,000 miles per hour, and commonly 750 miles per hour, raging in that upper atmosphere. And we're not quite sure why, so there's a little bit of mystery.
What puzzles scientists is why Neptune's winds blow even stronger than those on the other outer planets, with speeds 2 to 3 times faster than in Jupiter's blustery Great Red Spot. JPL researcher Michael Mishna studies what drives weather on other planets. He's intrigued by Neptune's mysteriously strong winds.
If we were to put one of these windmills up on Neptune, depending on the altitude that we put it, we would either see motion similar to what we see now, or if we were to place it at the altitudes in which the winds are going 1,000 miles an hour, we actually might not see very much motion at all. And that's because the atmosphere is so thin that there's just not enough oomph and not enough force from that wind to actually turn the propellers of the turbine. So you might not actually see any motion at all. On Earth, we see high pressure and low pressure systems if we look at weather maps, and the same to an extent can be seen on the outer planets. We can't exactly identify a big H in this location or a big L in this location. But there are generally regions that are warmer and have higher pressure than other areas which are colder and may have lower pressure, and that generates the winds that blow from high to low.
A key factor in the creation of wind is an energy source to heat the air. On Earth, the sun provides this energy. But the windswept planet Neptune is 30 times farther from the sun than Earth, and it gets only about 1/900th as much solar energy. It's simply not enough to power Neptune's colossal winds. Scientists believe that Neptune gets its additional power from within. Measurements taken by Voyager 2 showed that Neptune radiates twice as much heat from its interior as it gets from the sun. The highest ratio of heat outflow to inflow of any planet in the solar system.
Neptune has a relatively large amount of internal heating, which is coming from radioactive decay of materials inside and other chemical processes that are occurring, and that releases a lot of heat from the inside.
Just why the interior of Neptune generates so much heat remains a mystery. It's led some to speculate that the planet is still in the process of forming, and the infalling gases are releasing heat as they are compacted by gravity. This internal heat source could also explain the convection of gases in Neptune's atmosphere that leads to fascinating cloud patterns.
There are many bright white clouds that appear in the atmosphere. There are different regions of very bright and dark banding on the surface, so we'd be able to distinguish different latitudes by the brightness of the bands.
Scientists believe that the banding patterns have something to do with Neptune's cloud composition.
These are probably made of methane, and they move very fast around the planet as well.
Neptune's wind movement is unlike anything we are accustomed to.
These are giant storm systems that would dwarf anything that we see on Earth.
In 1989, Voyager 2 snapped a photograph that shocked the mission scientists. Neptune had a huge storm, a great dark spot in its southern hemisphere. Stretching 8,000 miles wide, large enough for our Earth to fit in the center, the storm resembled Jupiter's infamous Great Red Spot.
The Great Red Spot is a huge anticyclone, which is fed by many smaller storms that keeps it alive, if you like. Otherwise, it would dissipate and disappear. In the case of the Great Dark Spot, we believe it's more of an instability in the atmosphere, which rocks back and forth because of the flows in that very fast atmosphere.
First, the planet's rotation.
Venus has a very slow rotation, and it has what we call a retrograde rotation. So it spins backwards compared to the direction of spin of all the other planets.
Because of this retrograde rotation, the sun rises in the west and sets in the east. And the Venusian days are long ones. The amount of time from one sunrise to the next is about 8 Earth months. But the orbital pattern and long days aren't what make Venus so intolerable. In part, it's the wicked climate. With a surface temperature of 900 degrees Fahrenheit, Venus is the hottest planet in the solar system. Travelers there would have their trip cut short in no time.
It would take a matter of seconds, maybe 1 second before they were gone, roasted to death.
If you're an astronaut sitting on Venus without a spacesuit, then your skin's going to crisp up. You're going to cook just like a turkey in an oven, except much faster even.
The unforgiving heat wave is created by a process called the greenhouse effect, the identical process that keeps Earth's climate in check and teeming with life. But a closer look at Venus tells us how this common trait can be a cycle of life and a cycle of death. Today, our own temperature is on the rise, and scientists found the possible cause behind it up on Venus.
Global warming. is a result of greenhouse gases that are growing and growing and growing, and therefore we're getting hotter and hotter. When we looked at Venus, we said, aha, here it is actually happening.
In the 1990s, after the Magellan spacecraft was launched, planetary watchdogs began turning to Venus to surmise just how bad it could get here on Earth.
Space exploration has told us a lot about the Earth and the environment it's in. And in fact, the greenhouse effect that everybody's talking about with global warming was actually discovered on Venus.
What they found out about Venus shed new light on how fragile Earth's greenhouse effect really is.
And Venus didn't always used to be this hot. We think that early in its history, it was more Earth-like on the surface, and it lost its oceans due to what we call a runaway greenhouse effect. So Venus is an example that certainly that global change can happen on a planet, and it's sort of a worst-case scenario. We don't have to turn Earth into Venus before we're in trouble. We just have to move a little bit in that direction. And we are moving in that direction. But the real value of studying Venus, it allows us to test our climate models.
Through computerized general circulation models, or GCMs, scientists were able to calculate temperature increases on Earth based on the amount of greenhouse gases on Venus. So just how does Venus's greenhouse effect work and make the planet so hot? This is Biosphere 2. Located along the foothills of Arizona's Santa Catalina Mountains, it was built by a group of researchers to explore the idea of colonizing other planets. It is the largest greenhouse on Earth.
Biosphere is a perfect example of a greenhouse because it's a big building with glass panes that let the sun in, and the air is really hot in here.
The solar rays that penetrate the glass panes cause the temperature inside to rise.
The air heats up, but then the air cannot escape, cannot move vertically into the atmosphere because of the walls.
The windows trap the heat, warm the building, and provide the plants and trees with a livable climate. On Venus, greenhouse gases don't exactly trap the sun's heat, but they greatly slow the rate at which it can escape.
The greenhouse effect on any planet is a situation where the surface temperature becomes hotter because of gases in the atmosphere that trap the heat while letting in the sunlight.
These same greenhouse gases that would prove to be fatal to us on Venus are essential to life on Earth.
Without the greenhouse effect, the average temperature would be far below freezing, the oceans would be totally or almost totally frozen, and it's not even clear if life would exist on the Earth.
We talked about how hot it was, but why is it so hot? The answer has to do with the atmospheric composition. It's almost all carbon dioxide there.
Carbon dioxide, or CO2, makes up 95% of the Venusian atmosphere, and that high volume of gas traps more heat.
That's going to give you a strong greenhouse effect, and that's going to make it really hot. And that's why it's so hot on Venus. It's an extreme example of global warming.
On Venus, volcanoes are the natural spring source for CO2 and other gases. It's a process atmospheric chemist Jeff Sutton studies on Earth at Hawaii's Kilauea volcano. Deep below the surface, atomic compounds ignite during volcanic activity to form CO2. The gas is born from the pressure created by the heat of molten rock, or magma.
It rises towards the surface and reaches the summit magma storage complex. The pressure is decreased on the magma, and the effect of that is to allow gases that are trapped under the very high pressure to be released and bubble out.
The Venusian surface would likely have cracks in the lava similar to these vents, where gases escape into the airstream.
Somewhere between 8,000 and 30,000 metric tons of carbon dioxide boil out of the magma chamber each day. And it amounts to something on the order of 3.5 to 5 million tons per year.
And that's just one volcano here on Earth. Venus has more active volcanoes, and that means more heat-bouncing gases.
So all the CO2 just builds up in the atmosphere on Venus, which just makes it hotter and hotter.
The 900-degree heat isn't the only trait that makes Earth's twin seem a menace. 30 miles above the scorching ground of Venus, there's havoc occurring on the planet that makes 900 degrees Fahrenheit feel like a cold front. Electrical mayhem where split-second jolts can reach 50,000 degrees. Each spark of light contains 100 million volts of electricity. Lightning occurs on both Earth and Venus when electrical charges store up enough energy until they release a spark. Mears Oppenheim teaches planetary physics to students at Boston University. And researchers like him get in on the action at Boston's Museum of Science. In their caged lighting exhibit, 30-foot-high domes motor up to simulate how lightning is generated on Venus. And then, it's showtime.
So look at this. We're generating so many millions of volts on these domes that voltage has to escape. And it's actually ripping molecules in the air apart.
The air in the domes, like within the Venusian clouds, stirs up the electrical distribution of tiny atomic molecules.
So the ripped molecules make that light as they reassemble themselves, and that's what a lightning bolt is.
Cosmic particles from exploding stars way out in the galaxy trigger lightning. When these hit the atmosphere, they provide that spark.
These are particles that come from way out in the universe into the atmosphere and cause a shower of charged particles. And on Venus, you'd probably have real lightning to the extreme extent. It can contain enormous amounts of energy and go for miles and miles.
On average, lightning hits the Earth more than 3.1 billion times a year. The number of times lightning hits the ground on Venus? 0. The atmospheric pressure on Venus is 90 times greater than on Earth because the weight of the atmosphere created by gases is heavier. This prevents Venusian lightning from hitting hard ground. Instead, it is restrained to the clouds.
There's just too much resistance in that very thick air for a lightning bolt to get through. It's much easier for lightning to discharge from cloud to cloud.
And besides appearance, there's little else that's Earth-like about Venusian clouds. In fact, the main ingredient that creates them is toxic enough to burn through human flesh. From Earth, you might be able to see Venus twinkle in the morning and evening skies like a star.
Definitely not a wallflower. It's so bright in our sky, not just because it's the closest planet to us, but because it's the most reflective planet. Because it turns out Venus is completely covered in these bright reflective clouds.
80% of the sun's light bounces off the clouds that blanket the planet. But even in the clouds, Venus, our so-called twin planet, manages to show an evil nature.
And we know that the clouds of Venus are made out of sulfuric acid, basically like battery acid. And that sulfuric acid is made by sulfur dioxide coming out of volcanoes on the surface.
Like its greenhouse cousin, carbon dioxide, or CO2, gas pressure pushes sulfur dioxide to the surface through volcanic vents. It's the same gas chemist Jeff Sutton monitors carefully at Hawaii's Kilauea volcano.
The gases, the sulfur dioxide in particular, is the noxious, toxic gas. And we wear gas masks to protect our lungs and our airway because sulfur dioxide combines with the moisture in your nose and throat and forms sulfuric acid.
Sulfuric acid is nasty stuff. You don't want to splash battery acid on you. You're careful not to do that. It's basically the same stuff. So it would not be good to suddenly stick your hand into the Venus clouds.
So if a traveler to Venus could survive the acidic clouds, the lightning bolts, the toxic air, and the heat, just how would the Venusian surface look? Volcanologist Jeff Burns with the United States Geological Survey, or USGS, circles the globe to understand what drives volcanic activity on the inner planets. When Burns imagines the surface of Venus, he considers the dark, eerie wasteland of Kilauea's lava fields on the big island of Hawaii.
It's very instructive to be able to come here and study this volcano to compare it to volcanism that has occurred on the surface of Venus. We can actually come out here to the field and study things. We can actually take samples and look at them in detail.
Geologists expect the amount of volcanoes on Venus far outnumbers the 1,500 or so on Earth.
Some estimates range from 100,000 to over 1 million volcanic features on Venus.
With that many volcanoes, lava rock makes up 70% of the Venusian surface, just like it makes up much of Kilauea's terrain. The ground becomes solid when the lava cools into hard rock.
Having a rock on Earth is our best analog for trying to understand rocks on the other planets. Basaltic rocks are the most similar to the Venusian plains.
Basalt is the most common type of lava rock found on Venus and throughout the inner solar system. The minerals freeze into glass and small crystals, a total transformation from what lava looks like when it streams out of the volcano.
When lava is actively flowing across the surface, it's incandescent and typically looks red. Now, quickly it'll form a silvery sheen over the top of it, and then over a period of a few weeks will turn black, such as the lava we see around me here.
At 5 miles high, Mont Mons is the largest volcano on Venus. And it's left some tremendous lava channels in its wake, just like Kilauea did.
Now, as you can see, the structure, we have levees here on the sides, and then internal structures as well. This is similar, perhaps, to how large channels called canali formed on the surface of Venus. However, they formed at a much larger scale.
Large enough to create seemingly endless miles of canali across the Venusian landscape. Consistent in both width and depth, the canali are much longer on Venus than on Hawaii because of environmental conditions on the planet. The dense atmosphere and hot temperature slows the magma from cooling into solid rock. And with little wind and no rain to further cool the magma, lava can cut through the surface for months after an eruption before it hardens.
On Venus, if you did see layering, you would expect to see layer after layer of volcanic rock that would all be relatively black and basaltic in composition. You would probably see little bits of color due to potentially oxidized iron, which would look red. Typically, basaltic lava flows are glassy enough that, in fact, you would actually cut your hand. They can be extremely sharp. They tend to quench and form glass.
And then there are the skies. That heavy Venusian cloud cover diffuses most of the direct sunlight.
The So it would be a lot darker on the surface of Venus during the day than it would be here on Earth. Also, because the light is scattered very efficiently, you tend to lose shadows. So everything is lit fairly consistently across the surface. And then additionally, because of the composition of the atmosphere, everything would tend to have more of an orangish tinge to it.
Besides canyons, jagged mountain ranges scrape the Venusian skies. The planet's highest peak is on Maxwell Monts.
Maxwell is about 35,000 feet high, which puts it at a healthy distance above Mount Everest or any mountain on Earth. Everest is something like 28,000 feet high. So it's definitely larger than anything on Earth.
Our sister planet seems to have outdone one of our 7 natural wonders. But how would the Venusian terrain measure up against another geologic feature, our canyons? The Grand Canyon, a great chasm eroded over 250 million years by the Colorado River.
When the Colorado Plateau was uplifted millions of years ago, it gave the water more energy to cut back through the canyon and wear away the rocks.
The vast canyons on Venus may have also been formed by erosion, but not by a river.
Volcanic systems can erode canyons by having fluid flow. If it's very fluid, not very viscous, materials can erode similar to water. And the Grand Canyon is only part of the Colorado River system, but even looking at the Colorado River system as a whole is not nearly as long as the longest channels on Venus.
Had the ancient Romans known about the volcanoes, acidic clouds, lightning bolts, toxic air, and that scorching heat, perhaps they may have named our evil twin planet after something other than their goddess of beauty and love.
There's irony there because, of course, the Greeks and Romans didn't know anything about the conditions on Venus. And then here we are a couple thousand years later, and we're actually exploring this place, and, well, it's not quite so nice according to our taste.
But how do the dangers found on our sister planet compare to the cosmic violence on Mercury? 48 million miles away from Earth, Mercury's dust-covered hills and empty plains stretch as far as the naked eye can see.
It's a colorless body. I mean, it does not have really any colors like you see on Mars or the Earth or even Venus for that matter.
Dr. Robert Strong with the University of Arizona's Lunar and Planetary Lab has been a chief authority on planetary geology for more than 35 years.
Mercury is the innermost planet, and it's quite different than anything else in the solar system.
At 36 million miles, Mercury is the closest planet to the Sun. The planet has no known moons. Mercury has no atmosphere. And it's a naked eye planet, visible on Earth during the twilight hours. With a diameter 60% smaller than Earth, Mercury is the solar system's scrawniest planet. Much too small to generate the strong gravitational field needed to retain an atmosphere.
Gravity depends upon the mass of the object, on the mass. So the larger the mass, the more the gravity. So on Mercury, the gravity is less on there.
Since the planet's gravity is so weak, if you weighed 150 pounds on Earth, you'd only weigh 57 pounds on Mercury. Planet size matters when it comes to the internal heat needed to sustain geologic activity.
the internal convection currents that drive geology stop, and in general, it just freezes up and there's no way to sustain that geological activity. And that happened to Mercury a long time ago, probably after less than 1 billion years of its life.
The days when the planet beat with a strong pulse that produced volcanic and tectonic Mercury quakes are long gone.
Is Mercury a dead planet? Depends on what you mean by dead. Is it internally active now? Probably not. It's probably not active at all.
It is essentially a dead planet and has been dead for about 4 billion years.
For a near lifeless planet, Mercury still has some movement. Named by the ancient Romans after the swift-footed messenger god, Mercury orbits the Sun in 88 Earth days, the fastest of any planet. But when it comes to the time it takes Mercury to spin on its own axis, the planet holds the record for being the slowest. Length of time, around 180 Earth days, about half a year. The Sun's gravitational force creates a tidal friction within Mercury, which slows down its speed as it spins on its axis. This means a year on Mercury is shorter than a day on the planet. And that sluggish rotation gives Mercury a somewhat peculiar weather forecast. For 6 months, the side exposed to the Sun reaches 800 degrees Fahrenheit. On the other side, the temperature drops to 300 degrees below zero.
It has a long time to heat up on the side facing the Sun and a long time to cool down on the other side. And that's why it has these huge temperature extremes.
Despite its close proximity to the Sun, Mercury is a bit of a black sheep in the planetary family. Its skies always seem like starry nights.
The skies would be black. The reason we have blue skies on the Earth is because of our atmosphere. Nitrogen scatters light preferentially in the blue, and so that's why the sky looks blue. Mercury doesn't have an atmosphere, so the sky would be black.
Legend holds that Mercury, the Roman god, invented the sport of boxing. This is one planet that's taken the lion's share in the ring. Mercury has had millions of meteors and asteroids explode on its surface because it doesn't have an atmosphere to protect it. Our atmosphere guards Earth from most impacts, like a force field. When a small object slams into it, usually at more than 10 times the speed of a bullet, the collision with air molecules vaporizes it into a gas.
The Earth is shielded from small impacting objects by this wonderful thing that we call the atmosphere. And for small objects, weak objects, they will be completely destroyed by those forces long before they get here to the geologic surface of our planet.
On Mercury, without that atmosphere, the asteroids and meteors smack down at full throttle. This makes Mercury the most heavily cratered planet in the solar system.
You cannot take a step on Mercury without encountering an impact crater.
Back in 1974, the Mariner 10 space probe mapped half the planet's surface, including the largest crater ever surveyed in the solar system.
The most prominent feature is a feature called the Caloris Basin, which is a very large impact crater that is about maybe 900 miles in diameter.
900 miles in diameter. That's a couple hundred miles broader than the entire state of Texas. Researchers speculate the iron meteorite that made that impact stretched for more than 60 miles before it crashed into the surface. Moments after impact, seismic waves converged at the antipodal point, the spot on the exact opposite side of the planet.
The seismic waves, the shock waves from this thing traveled, and they've concentrated simultaneously around the other side of the planet and literally shook apart the surface.
The seismic turbulence jumbled up the crust and twisted the terrain into unusual rock formations.
There's all this weird terrain. In fact, the technical term is weird terrain. Because you look at it and it's just weird. It's this jumbled up and hilly and doesn't make any sense according to most geological activities. It's just very rough and looks as though somebody kind of scooped up the surface and just kind of dropped it down.
Pre-existing craters suddenly became crude hills, some 6 miles wide and a mile high.
In fact, the amount of surface elevation could have been on the order of a kilometer or two in just a few seconds. It would have been horrendous.
Scientists have no way of knowing exactly when the Caloris impact happened, but they can surmise one thing. If an asteroid the same size crashed into the Earth, the impact would be catastrophic and wipe out human civilization. Countless meteor and asteroid impacts have left Mercury scarred with dents and crater rings. Today, the planet looks beaten, a terrestrial corpse. Like Mercury, Earth's surface is vulnerable to bombardment. And Arizona's meteor crater is one of our most preserved and Mercurian craters. The desert basin has given geologists a better understanding of what happens when a meteor strikes Mercury's surface. Upon impact, energy from the shock wave rips through the surface and moves tons of rock upward to shape the crater.
And that flow of rock excavated this bowl-shaped cavity and deposited debris on the landscape for kilometers around. Same energy swept up the crater walls and caused these flat-laying layers of rock behind me to actually be uplifted. And the rock, under the influence of shock, wasn't behaving brittly like rock does, but more like taffy. This is one of the hallmarks of impact craters, not only here at Meteor Crater, but anywhere in the solar system.
But imagine if the mighty object that formed Mercury's Caloris Basin crashed down on the site of Meteor Crater.
It would be a massive explosion with chunks of molten material flying around the Earth ballistically, re-entering the Earth's atmosphere and causing just massive meteor showers everywhere.
For nearly 7,500 miles, the shock wave would rip up the soil and stir up tsunamis with 2,000-foot waves.
Massive tsunamis propagate around the Earth and inundate much of the world's coastlines.
It would flatten Las Vegas, Nevada, the cities of Salt Lake City, Utah, San Francisco, California, and Los Angeles would vanish in a split second.
Shock waves from the impact would propagate through the solid Earth thousands of miles from the site of an impact like that.
Those seismic waves would converge at the impact's antipodal point, off the coastline of Africa's Madagascar, at the bottom of the Indian Ocean. Suddenly, a mountain range would explode through the ocean floor and crash up to form that weird Mercurian terrain.
Like an unbelievable earthquake, probably everywhere on Earth for an object that large.
Meteor Crater would be a nick in the surface compared to the Mercurian gash left behind from a Caloris-type impact. The gouge would consume a quarter of the continental United States.
An object that size would eliminate a large portion of the west coast of the U.S. If it fell, say, on Arizona, it would literally change the coastline in an instant.
Back on Mercury, those craters give it an iconic stature in the solar system, and some of these pockmarks harbor mysteries. When the radar at Puerto Rico's Arecibo Observatory honed in on Mercury's poles, it picked up something that left researchers befuddled.
Ice, of all things. One of the hottest bodies in the solar system, and it has ice in the poles. And the reason it has ice there is because Mercury is a heavily cratered surface. And so craters in the polar regions, the inside of them, are constantly in shadow.
That's because Mercury is vertical relative to the plane of its orbit. So some crater floors never receive light or heat from the sun. But with no obvious water source on the planet, that begs the question, how did the ice get there? Scientists believe the mystery ice could have come from a comet. Comprised of rock, dust, gases, and ice, comets come from the outer reaches of the solar system, where the temperatures are much colder.
Could this ice just be on the bottom of permanently shaded craters, or could it be ice that's sort of covered up by a layer of dust which is shielding it from sunlight? We really don't know.
Besides these comet collisions, there is yet another type of crater on the planet, and they weren't formed by anything that fell from the sky. Instead, an Earth-like force of nature created these holes, and it generated deep from within the planet's core. Mercury. A closer look at its terrain by scientists reveals that some of its craters could have been formed from something other than asteroids, comets, and meteors.
We do understand that the dominant geologic process that affected Mercury, at least Mercury's surface, is impact cratering. The second most important geologic process to affect Mercury is volcanism.
Although we haven't seen any definite evidence of volcanoes on Mercury, we do expect that there have been volcanic eruptions in the past.
This remote cow pasture, a 3 hours drive north of Phoenix, might contain a telling link to Mercury's volcanic history. The cratered hills are extinct cinder cone volcanoes, and geologists suspect similar ones can be found on Mercury.
This is a cinder cone. You can see behind me there's a large crater in the center, which is typical of cinder cones.
These volcanoes do have their differences with Mercury's cinder cones.
Because Mercury has less gravity, we would expect the cinder cones that form to be much wider and much flatter.
All volcanoes erupt when the pressure from the magma, or molten rock inside, is greater than the strength of the rock containing it. Pressure increases for two reasons: too much magma and too much gas. And when pressure increases in a volcano, it usually has one place to go.
Lava comes up to the surface and erupts explosively. You have a vent area and you have what's called a fire fountain.
If the pressure is great enough, its force can spew lava higher than 100 feet on Earth. But on Mercury, with such low gravity, the fountain could eject lava 30 stories high. While these cinder cones in Arizona may illustrate our shared volcanic heritage with Mercury, to witness an eruption there firsthand and watch the cinder cones form would be a whole other experience. first, without an atmosphere, a plume of ash and smoke and debris wouldn't billow across the landscape.
That material would go into essentially a vacuum of space because Mercury doesn't have an atmosphere, so that material would break up much more.
Also on Mercury, you wouldn't be able to hear the loud eruption.
Since Mercury has no atmosphere, there's no way of transmitting sound. So if you were on Mercury and playing a guitar or a ukulele or a piano, you would not hear anything because there is no atmosphere to transmit that sound. So it would be just complete silence.
Back in 1974, Mariner 10 surveyed only 45% of Mercury's surface on a flyby mission. 30 years later, NASA launched the Messenger spacecraft. The satellite will map the entire planet and transmit data to eager scientists with a deluge of unanswered questions.
I want to see the other side. I don't know what's over there, and that's been bugging me for 35 years. Is it like the side we saw, or is there something very unusual and different?
But even with resources being earmarked for future exploration of this rumpled dwarf in the solar system, exactly how different or similar we really are may be left up in the air. Despite the harsh conditions on Mercury and on Venus, a close look around our own backyards reveals the good, the bad, and the ugly of the inner planets.
The universe is this vast, vast thing, and here we are sitting on this little pinprick. I mean, we are not isolated.
We see things that happen on these other planets for tremendous climatic changes in the past that have happened in a very short period of time and changed that. And that can happen on the Earth.
Ultimately, it enriches our knowledge of who we are and how unique and how rare an environment like ours and even creatures like us might be in the universe.
And that evolution, that exploration, that turning the corner, that discovery of new ideas is what we're all about. There's a bright future.